is about where you need to go to get your 140-degree angle. If I said graph a 10-degree angle, and you do this, don't get upset if I counted wrong. Is that a 10-degree angle? No, that's about a 25-degree angle. All right? 10 degrees, you got to look at your two sections here. 10 degrees, this is 30 degrees, right? So you need to be able to split them into about 3 equal sections to show that this is 10, 20, 30. And then draw your 10-degree angle. Now, what happens if I say graph a negative angle? You go in the opposite direction. And you start counting backwards. If this was 30 degrees going this way, then this is 30 degrees coming this way. Yes?
So whenever we're graphing on the test, they're going to have like all those lines saying like 60, 45.
Right.
So.
You're going to have, I'm going to try my best to get this picture right here on your test. Okay? Now, I'm not going to obviously say graph a 90-degree angle. No. I mean, that's like a test question for a kindergartner. You're going to have to, at least try a little bit and get your estimated correct. Okay, let's say I asked you to graph, we're going to do a negative and a big number all at the same time. A negative 690-degree angle. Okay, well, the first thing is, if it's negative, it means from my initial side, instead of going this way, I'm going the other way. Now, how much is a whole circle? 360. So I start counting. If I start here, I've got to go all the way around, and that's 360 degrees. Now, it's not another whole circle, is it? Because that would be 720. So what's left from 690 and 360? How much more do I need to go? 330 degrees. All right? This is 90. This is 180. This is 270. 270 plus 30 more would be 300. Plus 30 more would be 330, right? And that's where you would stop. And you would draw this. Because you want to have your starting side and your ending side, but this arrow shows you the direction that you're going and how many times you have to go around to get there. So think of it as the clock, going around and coming around again. Okay, that's fine. All right, let's say we graph an 810-degree angle. Here's my initial side. 810 is how many full circles? 2 full circles, which is going to give us 720, right? And then we need to figure out how much more we need to go. Another 90. Okay, so 1 full circle is 360, plus another 360 is 720, and 720 plus another 90 will get me to 810. So that would be your angle. Okay? Does everybody understand this and what's going to be expected? Speak now or...
Why can't they just say 90?
Or don't speak later. Because it's not just 90. This could represent a clock and say in 2 hours and 15 minutes. That would represent 1 hour, 2 hours, and 15 minutes. For the graphing part. All right, and then this. Sine, cosine, and tangent. SOHCAHTOA. SOHCAHTOA. Meant to help you remember what goes together. Remember, sine and cosine both deal with the hypotenuse. So if there is no hypotenuse labeled, you automatically know you're going to be using tangent. Sine of your angle is equal to the opposite leg over the hypotenuse. The cosine of your angle is the adjacent leg over the hypotenuse. And the tangent of your angle is equal to the opposite leg over the adjacent leg. How do you identify the hypotenuse of a right triangle? It's the longest side. Now the hypotenuse is always right next to your designated angle, so don't get it confused and call it the adjacent leg. It's not a leg, it's the hypotenuse. In this triangle, you're going to have triangles such as this, where you will have things labeled and you have to solve for the missing variable. Annalise and Catherine, can you pay attention, please? This is all it's going to be, and it's going to say solve for x. You've got to determine which function to use. Now remember, the function does not come first. How do you decide what function to use? The angle. You always start with the angle. In reference to your designated angle, what do you know? Or let's say this, what do we not know? We don't have anything about the hypotenuse. So automatically we know we should be using the tangent function. So the tangent of our angle is equal to the opposite leg over the adjacent leg. Which one's opposite the 44-degree angle? X is opposite. That means 12 is adjacent to the 44-degree angle. So you need to know your function, you need to know how to set it up, and you need to know how to use your calculator. With this type of problem, how do you plug it into your calculator? To get x by itself, we would have to multiply both sides by 12. So you're entering 12 times the tangent of 44. It's 11.58 or 11.6. You will have directions on your test on how to round and what place to round to.
That's all you want us to find?
For this type of example. Yeah. In this example, we have three parts of the triangle labeled. We start with the angle. In reference to the angle, let's start here. Is the hypotenuse labeled?
Yes.
So that means we're either going to use sine or cosine. Now how we determine that is by figuring out what this is. Is this opposite the angle or adjacent to it? It's opposite. So that would be the sine of my angle is equal to the opposite leg divided by the hypotenuse. And we need to know how to use the calculator. What is essential to press when you've got this going on? Shift. You are looking for the angle, so you must use your shift or second key. So you would say second sine, 9 divided by 15 equals. And for angle measures, we're going to round to the nearest whole number, so that would be 37 degrees. All right, and then you're also going to have